Hi guys, in this video I'm gonna go over the homework problem, page 83, number 11. The problem technically opened a can of worms and we just have to deal with it and remember all the algebra concepts that you learned before. I know that that section was mainly graphing, but this problem included imaginary roots, and therefore we have to find quadratic equations hidden in that trinomial to be able to kind of extract the imaginary roots. So first of all, how you maybe would approach it is to factor, because it does factor. And that's what you're gonna get. That x cubed equals 8 and x cubed equals -1. You're gonna cube root. That will give you 2, and that will give you still -1. So those are the real roots, and that's okay if you're graphing. It's not a big deal because if you look at the graph, so if you remember, we can factor these two by SOAP. I'm sure you've all heard of it. So if I have a cubed plus b cubed, that would factor to a plus b, and then a squared minus ab plus b squared, and SOAP would represent that the sign on the first parentheses right here is, let me see, right here is the same as the given equation. So same for S. And then in the second quadratic factor, that's the opposite sign of whatever is in the first parentheses or in the original equation. So that's opposite sign for O. And then that's always positive for the AP. So it goes same, opposite, always positive. Same sign as the equation, opposite sign from the equation, and then that's always positive. So if I had minus instead of the plus in the original equation, that would be the same. So minus, that would be opposite, plus, and that would be always positive. So that's the general rule in here. Let's factor each one to try to find that quadratic that's hidden in there to be able to find the imaginary roots. From Desmos here, it will show you that it will go through, since it was x cubed. It's an odd power, so that will go through the x-axis. It will not bounce, so it's not going to affect your graph per se, but since they asked for the imaginary roots, then we have to go and do more work to find this. But if you were to graph, this would be perfect. You'll know that these are your real roots, and that's pretty much all you need, and they will go through, and that's good. Okay, now since they want the imaginary roots, we have to remember how to work with that cubic factor. So I factored x cubed minus 8 following that rule. It will be x minus 2, because 2 is the cube root of 8. And then the quadratic equation, or the quadratic factor, is x squared plus 2x plus 4, so ab, 2 times x, and also b squared, and then a squared. X cubed plus 1, the cube root of x is, cube root of x cubed is x, the cube root of 1 is 1, and then it goes that the first term is squared, and then first times second, so over here negative x, because we said opposite sign, and then the last term is squared. So I go and I factor each one, and that's what I get. So I know when I factored that I got 2 as a root, and we saw the graph, it went through. We thought it's a triple root, ended up being just one, but it's not going to affect my graph. If I want to check if it's a triple, just to make sure, I'll try to do synthetic division, and that will confirm if it's a triple root. So if I do synthetic division, 2 will actually divide that with no remainder just once. So it actually won't go in a lot of times. So if you say triple, technically it's not, because by synthetic division it didn't work. It didn't end with 0 as my remainder. It actually gave me a remainder after I did it by synthetic division after the first time. So on the test, I'll tell you, check if it's a triple root or find how many roots, and I did that on the quiz, and you did synthetic division to figure out how many times it would go in. This gave me -1, same thing, we thought it's a triple. Ended up not being, because if I do synthetic division, it would actually work just once, and then the second time it will give me a remainder. This is actually just one. But again, it won't affect your graph. So if you do it that way and you graph it, you're gonna be fine on that problem. So now the rest is quadratics. I can find imaginary roots from these by using the quadratic formula. So if I do the quadratic formula in each one of these, I'll find the imaginary roots. And I think these were... So this will give me -1 plus or minus I rad 3, and this will give me a half plus or minus rad 3 over 2I. And there you go. Those are your roots, 2 imaginary, and then 2 real, and then 4 imaginary.